All right, so if you guys did not copy the objective down by now, it is at the top of the slide over here. You guys can copy it. But for prior knowledge here, it says we need to find the mean, the median, and the range from the data below. So if you remember, to calculate the mean, you want to take the sum of all the numbers and divide by the number of values. So in this case, add all of those numbers and then divide by 14 because we have a total of 14. For the median, remember this is the middle number, whichever number is in the middle. And then for the range, how do we calculate the range? Do you guys remember for range?
You add the lowest number and the highest number together, right?
Not add, but subtract. Max minus the min. Okay? But remember, before we can do any of that stuff, the very first thing is you need to put them in order from least to greatest. Okay? So you guys go ahead and calculate those three values for me in your notes. Okay, so for today's lesson, we're going to be focusing on dot plots. It's a data representation that uses a number line and X's or dots or other symbols to show frequency. And then dot plots are sometimes called line plots. So if you remember, frequency kind of basically means how often something happens or occurs. So our dot plot is going to be on a number line, and we're going to have values on top of, or X's or dots on top of the values. So for example, here I see 1X, that tells me one person answered 3. And then for 6, I have 3 X's, so 3 people, that's the frequency is 3, said 6. So in this context, it says this dot plot shows the number of states each person in Kevin's family has visited. So each dot represents one person, and the numbers on the number line represent the number of states visited. So you can tell how many states each person has visited. Again, here I can see one person has gone to 3 different states. I can see 3 people went to 6 states, 2 people have visited 7 states, and 1 person has visited 8 states. That's how I read the dot plot, okay? So every X above the number is representing a frequency. And then next we're going to learn about like skewed left, skewed right, or symmetric. So we have the distribution that is mounted but not symmetric because there's one tail is much longer than the other is called a skewed distribution. So when the longer tail is on the left, we say it's skewed left. If the longer tail is on the right, then we say it's skewed right. So I can see in my picture here, this has a longer tail on the left side. So it has a left tail. So we say skewed left. This one has a right tail. So we say it's skewed right. And if it's equally distributed on both sides, then we say that's symmetric. Okay? So these are approximately equal. So we say it's symmetric. It doesn't have to be exactly equal, but just approximately equal for it to be symmetric. Okay? All right, so for today's lesson, in order to create a dot plot, first you need to organize your data by rearranging them in order from least to greatest. And then you want to draw a number line that corresponds to the range of the values that covers all data points. And then step 3 is place a dot or an X above the number line to represent each data. So if we look at our first example here, it says the data below represents the GPAs of 16 students in the art club. We're supposed to create a dot plot and then describe the data as skewed left, skewed right, or symmetric. All right, so the very first thing it said to do was to organize in order from least to greatest. So these are decimal values here. I have a 0.5 is my smallest value, so start with 0.5. Then looking for the ones, I have this 1.5 right here. I don't have any other ones, so then move on to the twos. I have 2.0. Then 2.5s, I have 1, 2, 3 2.5s. Yes. Yes. 3 2.5s. And then for 3.0s, I have 1, 2, 3 3.0s. 3.5s, I have 1, 2, 3, 4, 5 3.5s. And then that leaves me with the 2 4.0s. And it looks like I got all of them. Double count. Make sure you have 16 values. I have 16. Make sure you have 16 values. All right, then for my number line, I need to figure out my scale. So my smallest number I have is a 0.5, and these are kind of going by 0.5s anyway. So 0.5, 1.5, 2, 2.5, 3.0, 3.5, and a 4. So I can go by half on my scale. But I'm only going to label the whole number. So this is going to be 0. My middle one's a 0.5. Then that's going to go to 1. And then 1.5, 2, 2.5, 3, 3.5, and 4. And I could go on all the way to 5, but I don't have any values for 5. You could put 0, 0.5, 1, 1.52, 2.53, 3.54, 4.55, but then your number line gets kind of crowded, and sometimes it doesn't fit every value down here. All right, so then to create my dot plot, I need to go put a dot for however many values I have for that number. So for example, I have 0.5. So I'm going to put at 0.5, 1x or dot. Then I have 1.5, so go put 1x for 1. Oops, that's not 1.5. Go put 1x at the 1.5. Then I have 2.0, so put that 1x on the 2. Then the 2.5, I have 1, 2, 3 2.5, so put 3 x's above 2.5. So 1, 2, 3. And then 3.0s, I have 1, 2, 3. So 3 x's above the 3. 3.5s, I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then I have 1, 2, 4.0. So 2 x's above the 4s. And that creates my dot plot. So again, put 1x above each value that shows up. So 1.5, I have 3.0, so 3 x's represent 3 of them. Okay? And then the other thing we need to talk about is the describing. So it says describe the data as a skewed left, skewed right, or symmetric. So in order to do that, the best thing you can do is, or the easiest, I guess I could say, is draw a curve over your values like this. And then check is my distribution equally distributed on both sides, or do I have a longer tail on one side? Longer tail. I do have, this is a longer tail. And is that the left side or the right side? This is the left. So I have a left tail. I'm looking at the direction of the tail, not where the hump is at. I'm looking at the tail, okay? So my tail is on the left side. My data is getting pulled to the left, so it's skewed left, okay? So the data is skewed left. Oh, that doesn't matter. I just was just drawing a curve. I could have started here and then go this way, but the tail is still on the left side. Yeah, it's like it's going like downhill. Yeah, sure. So yes, but like the lower values here are getting pulled towards the left side. It's like going downhill to the left. So it's skewed left. If it was going downhill to the right, we say skewed right. All right, so I'm going to have you guys try this next example. And then you guys can try it, okay? So it says the data shows the hourly wage for the employees at a glass making company. You're supposed to create a dot plot and then describe the data as skewed left, skewed right, or symmetric. And I know you have some values that are missing, so I'll zoom in so you guys can see those values. So you're going to go create your dot plot. And they're already in order for you, so you don't have to put them in order. Create your dot plot and then determine if it's skewed left, skewed right, or symmetric. So here you guys should have had 1x for 25, 2 for 30, 4 for 35, 3 for 40, 2 for 45, 1 for 50, and 1 for 65 over here. If you were to draw a curve for this, notice that 65 is pulling my data to the right side. If that 65 wasn't there, it would have stopped from here to here. So that would be roughly symmetric. But because of the 65, I end up with the longer tail on the right side. So because I have a longer tail on the right side, we say it's skewed right. Okay? All right. The next thing we need to talk about is the outliers. So is the value far enough to be considered an outlier? An outlier is a value in the data set that is much greater or much less than most of the other values in the data set. Outliers are determined by using the first or third quartiles and the IQR. So how do I identify an outlier? A data value is an outlier if the data value is less than Q1 minus 1.5 times the IQR, or is greater than Q3 plus 1.5 times the IQR. So that's going to be my lower bound and the upper bound. So my lower bound, LB, that stands for lower bound. We're going to take Q1 minus 1.5 times the IQR. My upper bound, or UB, upper bound, is Q3 plus 1.5 times the IQR. All right, so those are going to be my boundary lines. If there's anything outside of those two boundary lines, then we're going to have outliers, okay? So notice the one with Q1, we subtract. That's because if you think of a data, let me do something really quick. Like if I had 2, 2, 3, 4, 5, 6, 6, my 4 is going to be the median. My 2 is going to be the Q1, and my 6 is going to be our Q3. So for outliers, the reason why we subtract Q1 minus is because Q1 is the lower bound. So we're trying to, the lower median of the lower half. We're trying to see how far to the left we can go and how far to the right we can go from the Q1 and the Q3 to be considered an outlier. So in this case, for Q1, we subtract because we're going to the left. Q3, we add because we're going to the right. Okay? All right, so let's go ahead and look at our first example here. It says we have the dot plot shows the results of a survey of students about the amount of time in minutes they took to eat breakfast. We're supposed to find the mean, the median, the range, and any outliers if necessary. And then it says round the mean to the nearest 10. All right, so for the mean, remember you have to go add all your values together. So this is going to be 1, 3. This has 2 7s. So 2 plus 7 gives us 14. Right now I'm just adding. So 2 7s gives me 14. 2 8s gives me 16. 3 9s gives me 27. 3 10s gives us 30. Then I have 1 11. 2 12s gives us 24. And then 1 13. So basically go add those values up. And that'll give us what they add up to. Okay? Again, I have 1 3. So I could go 3 plus 7 plus 7 plus 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 10, right? But to make it easy on myself, I just added the individual ones. So 2 7s is 14, 2 8s is 16, 3 9s is 27, 3 10s is 30. I have 1 11, 2 12s is 24, and then the 1 13. And we have a total of 15. It was 138, you said?
Yeah, 138 over 15.
Okay, and we have 15 values. So go ahead and divide those for me. You guys get 9.2?
Yeah, 9.2.
Okay, what's my units here? What is it talking about?
Time.
Minutes. So the mean amount of time to eat breakfast is about 9.2 minutes. Okay, my median. Remember, the median is the middle number. So in a dot plot, you can just go cancel out stuff until you get to the middle. So for example, I have one value here, one value here. I'm going to keep going until I get to the middle. I have 2 from here, 2 from here. I have 2 from here, 2 from this side. And then I can cancel out 2 from this side, 2 from this side. So then I end up with this value in the middle, which is 9. So my median is 9 minutes. Okay? Again, what I did was go from the left to the right, cancel until you get to the middle value. So the middle value ended up being 9. If you end up with 2 in the middle, remember you have to average them out. But in this case, it was just 1 in the middle. All right, so I got the mean, I got the median. Now I have to do the range. So for range, remember we do the max minus the min. So what's my maximum value? 13 minus the minimum is 3. So that ends up for 10 for the range. Okay. The last thing I need to do is calculate for the outliers. So for my outliers, remember my I'm going to need the Q1, the Q3, and the IQR. So my Q1 is given to me right here is 8. Q3 is 11. I'm going to need the IQR. So if you remember IQR, think back to what we did on Thursday and Friday. How do we calculate the IQR?
You use your quadrant 1 and quadrant 3.
And what do we do? What do we do to the Q1 and the Q? Well, you want the bigger one. Q3 would be the bigger one minus the Q1. Oh, okay. So for my Q3, I get 11 minus 8 for Q1. So IQR is what? 3. Then for my lower bound, I'm going to do Q1 minus 1.5 times the IQR. My Q1 is 8, so plug in 8 minus 1.5 times my IQR is 3. So on the calculator, you can just do 8 minus 1.5 parenthesis 3 close parenthesis press equals. Yes?
So newbies will use quadrant 3?
Yes. What do you guys get for your lower bound?
3.5.
3.5? My lower bound is 3.5. Now for the upper bound, we're doing Q3 plus 1.5 times the IQR. So my Q3 is what? It's off my screen, I can see. Q3 is 11? Thank you. So Q3, we're doing 11 plus 1.5 times IQR is still 3. So it's 11 plus 1.5 times 3. So on the calculator, just do 11 plus 1.5 parenthesis 3. Lower bound, upper bound, yes. That's just the formula. 15.5?
Yeah, it's 15.5. What would you get? What?
Quiet, please. Eyes up front. Okay, this is now my lower bound and my upper bound. So what I'm going to do is I'm going to draw my lines on the number line. So my 3.5 would lie right here between the 3 and the 4. And 15.5 is going to be like way over here. Okay, those are my boundary lines. Basically, anything on the inside is okay. They're not considered any outliers. If you have anything outside of those two lines, like this value right here, that's outside, so then that's considered an outlier. That 3 right there is far from the other ones, and it's far enough to be considered an outlier because it's outside of the boundary lines, okay? So in this case, my 3 ends up being an outlier. Okay, so I would say 3 minutes is an outlier. Yes?
What if the lower bound or upper bound is directly on one of the numbers?
Then it's not considered an outlier. All right. So one more time. For your lower bound is Q1 minus. The 1.5, that's just the formula. And then the upper bound is Q3 plus the 1.5 to the IQR. Once you get those two values, those are your like boundary lines. So I think it's helpful if you draw your boundary lines, and then anything outside of it is considered an outlier. So I want you guys to go ahead and try with this one now. I think your fill in the blanks are Q1 is 24, Q3 is 26. You should have everything else in your paper. So go ahead and do this one. You're finding the mean, median, and range, and determine if there's outliers here. All right, what is your guys getting for what they add up to? What did they add up to? 405. If we divide by 16, what did you guys get? 25.3. And units is years. Okay. Median. What number was in the middle? We have a total of 16. So 16 divided by 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8 on this side. And 1, 2, 3, 4, 5, 6, 7, 8 on this side. So we end up with 2 of them in the middle, right? We end up with 2 in the middle, so that'll be 50 divided by 2. That's still going to be 25 years. Okay. For my range, what's the maximum? Minus the minimum is 22. So what does that give you? 9 years? Yes? Okay. What did you guys get for your lower bound? 21. And the upper bound is 29. So if you draw your boundary lines, 21 is right here. 29 is right here. So is there anything outside of those two lines? 31 is on the outside, so this is considered an outlier. Okay, so 31 years is an outlier. Period.